Hi and welcome to the fourth video on kinematics. Today we'll be dealing with displacement, velocity, and acceleration when these three are given as functions of time. Now, the procedure that we have to take is the calculus route. Now, you can write down this abbreviation x, and in the middle we'll have velocity, and at the end we'll have acceleration. Now, to move from displacement to velocity, we have to differentiate. So if you've been given a displacement equation, you can differentiate it and get a velocity equation. Given a velocity equation, you can differentiate it and get the acceleration equation. Now, the opposite is true. If you've been given an acceleration equation, you can integrate it and get the velocity equation. Given the velocity equation, you can integrate it and get the displacement equation. So feel free to take a screenshot of this summary here. Now, in the question, we've been given a velocity equation. V equals 6 minus 3t. What have we been asked to get? We've been asked to find the displacement and the acceleration of the particle at instantaneous rest. Now, I'll make another comment about instantaneous rest. Instantaneous rest is when an object is moving, then it stops for a very short period of time. Picture a pendulum swinging. I'm not saying this is a pendulum, but you can picture instantaneous rest using a pendulum. So when a pendulum is swinging from one side to the other, there's a point where it stops in the middle of the air and then comes back. It swings back to its original position. So when it's going this side, it has a certain velocity, but when it reaches its maximum point, it stops momentarily. You can think of this as instantaneous rest. So, since we have two parts in this question, we've been given a velocity equation, which is 6 minus 3t. We've been asked to get the displacement and the acceleration. So at one point, using the velocity equation, we integrate to get the displacement equation, and then we'll also differentiate to get the acceleration equation. Now let's do a brief on the power rule of differentiation. So if you've been given a function y equals x to the power n, to differentiate this equation, we get dy dx is equal to, the power rule says that the power has to go down, so that's n x, then n, you subtract 1 from the power. That's how we differentiate an equation. So here if we have 3t to the power 1, to differentiate this, it will become, we drop the power, which is 1, 3 to the power t, 1, then we subtract 1 from the power. So this will be 3t to the power 0. And anything to the power 0 is 1. So that's 3. We'll get to this later. And now let's talk about a brief on integration. So when we're integrating x with respect to x, x to the power n with respect to x, this becomes, we add 1 to the power, so it becomes n plus 1 divided by n plus 1. So if we're integrating, say, something like x to the power 5 dx, this dx means with respect to x, we'll say x to the power 5 plus 1 divided by 5 plus 1, which becomes x to the power 6 over 6. With that in mind, let's get into it. So we've been told that this particle is at instantaneous rest. Let me read the question. A body moves in a straight line along the x-axis. Its velocity as a function of time is given by the equation v is equal to 6 minus 3t, where x is in meters and t is in seconds. Find the displacement and the acceleration of the particle when it is at instantaneous rest. The most important thing for you to know at instantaneous rest is that the velocity is equal to 0. V is equal to 0 at instantaneous rest. So if we plug 0 into this equation, 0 is equal to 6 minus 3t. We take 3 on the other side, we get 3t is equal to 6. Divide 3 both sides. This gives us t equals 2 seconds. So this is the time that we're going to be using. T is equal to 2 seconds. Now let's begin by getting the displacement. So we've established that to get displacement, we need to integrate the velocity equation. The velocity equation is 6 minus 3t. So that will be the integral of 6 minus 3t with respect to t. Now, this has to have an upper and lower limit. The upper and the lower limit are going to be time. What's the upper limit? 2, because that's the final time. Now, what's the lower limit? Here is where we know where the particle starts. Given that the particle is initially at the origin. So if we have a graph, the origin is the 0, 0. That means that initially it was at 0. So in integrating, we have to take note of that. Let's begin the integral process. If we have 6, it's the same as having 6t to the power 0. So I'll keep the integral sign. 2 and the lower limit is 0 minus 3t. This is the same as t to the power 1 dt. Now when we integrate this, this will become 6t to the power 0. We add 1 to the power, then we divide by the new power, minus 3t. We add 1 to the power, divided by the new power. All this, we still have to apply the limits. This becomes 6 to the power, or 6t, 0 plus 1 is 1, minus, and then 0 plus 1, so this is divided by 1, minus 3, t to the power 1 plus 1 is t to the power 2, divided by 1 plus 1 is 2. Still have to apply the limits, 2 and 0. Now this becomes, and remember, we're getting the function. We have to start with the upper limit. So that's 6. We put 2 minus 3. This is also over 2. Then 2 squared minus the lower limit. The lower limit, we'll put 6, open brackets, 0 minus 3, 0 squared. This is over 2. Here we get 12 minus 3. 2 squared is 4 over 2 minus 6 times 0 is 0. 3 multiplied by 0 divided by 2, that's also 0. This gives us 12 minus, we can cancel 2 here and we have 1 there, leaving us with 12 minus 6 minus 0. This gives us 12 minus 6, which is equal to 6 minus 0. This gives us a displacement of 6 meters. Next up, we want to get the acceleration. So the acceleration, to move from velocity to acceleration, we differentiate this equation. So we've been given the equation v equals 6 minus 3t. When you differentiate this equation, we get dv dt is equal to, we differentiate 6, we get 0. When we differentiate negative 3t, we get minus 3. Because it's t to the power 1, the 1 drops, then it will be 1 minus 1, 0. So this becomes the equation of acceleration. Therefore, acceleration is equal to negative 3. And the units are meters per square seconds. Now notice that we don't have any t in the final answer for acceleration. What does this tell us? This tells us that acceleration is independent of time in this case. That means that the acceleration is not changing with time, it is constant. If we had something like acceleration equals negative 3t, it means that the acceleration is changing every time that t changes from either 2 to 3 or whatever other number. But in this case, it's just negative 3. That means that the acceleration is constant and its value is negative 3 meters per square second.